Welcome, folks. Rajita, I sure you have Rajita both. This
Ragita
is
cloned himself.
this is the Kubernetes Book Club. Today is October 27. Um, what's the problem with the invites? I think there's some background noise background on the back, like fan or something.
Vegeta, I think your microphone's picking up
Okay,
noise. There it
that's
is.
how.
Thank you.
Yeah, I put thing. Um, So yeah, welcome, folks. You've seen this on YouTube. CKA exam, Acing the CKA exam book by Chad. Today's chapter 6. Please follow the code of conduct. The link is in the notes, and you can access the code of conduct there. If you want to follow along, you can get the book. Usually there's coupons. Ask in Slack if there's a coupon. And then for news, what's going on? Cloud Native rejects the weekend before KubeCon. KubeCon is November 6th to the 9th, and then the CFP for KubeCon Paris is still open until November 6th. I don't know if there's any other news we want to add. Eric is having.
Istio exam will be open soon.
I
To
saw some.
I don't know if it's preview, so it will be exciting to hear about it. So
Yeah.
I've been seeing some efforts on the Istio exam channel. So people have already started working on it. I'd like to check how it
Yeah,
looks.
Marino is doing a session or did a session. I can put in the channel also on that.
Let me try to find the links. Yeah.
And then today, Eric is going to help us with the chapter is called Communication in Kubernetes. I promoted it as networking. I think most people think it's networking and communication is okay. But some people know it as networking. So that's the chapter 6 on the exam. You will need to know certain aspects of knowing like CNIs, pod-to-pod communication. Doesn't mention Ingress, DNS, assigning pods, and the type of services. We'll let Eric show his screen.
Okay. Screen share going. My dogs are going to start barking and growling right now because I'm starting to talk. So I apologize in advance. I tried to record something last week, and as soon as I hit record, every time. Hush. Sorry. Hold on a second.
Now he's mad.
Sorry about that.
Really mad.
Okay. So
Upset.
here we go with communicating in a Kubernetes cluster. I swear, every time somebody's at my door. Sorry.
Your dog is adorbs. He just wants to be part of it. He just wants to be part of the community.
Start the chapter up, Carlos. I'll be right back.
Sure.
Let me see. Let me see if I can. Oh, I cannot take over the screen share. Somebody else is sharing.
No.
Okay, they're
interesting.
Okay.
Okay, so this is all about networking. It says communication, but that means networking. And of course, he goes over the normal parts, sections that are going to be covered by the test. And we dive right into DNS. So DNS in Kubernetes obviously is important. You're seeing my screen, right?
Yep.
So
Yep.
Okay. As it serves as the service discovery mechanism for everything inside Kubernetes. The first test, and I've automated my stuff here, so hopefully this will be very easy and no typos. So first, we want to make sure we're in the right context. We have 3 clusters actually in this exam in this chapter. So we've got this one, the normal one we've been using, the single node. later on, we're going to have one that's set up for doing ingress and one that's set up for installing a CNI. So I bring that up because you're going to see me setting context in between each of these sections. And this is something you need to practice. I think we probably beat this a lot, but in the test, every question will have set your context to this.
Yep.
And you always want to do that because you don't want to be messing around in the wrong context and lose your place. So I'm in my kind cluster, and you can see that I have several. That's why.
Just show a tip. How do you know you're in the right context
So I switched
from
the
the
context.
CLI?
Yeah, if I look up here where I got contexts, when I created my
Mhm.
3 clusters, it created these 3 kind clusters, contexts.
Yep.
The star shows me what
Star.
I'm in.
Yep.
And even though I knew I was in the right one, I still set it just because I want to be anal about it.
Yeah.
And I also pull a Docker PS just to look at what my with kind, it's wrapping, each node is wrapped in a Docker container. So you can see there's a CNI control plane. Let me full screen this. CNI control plane, CNI, that's the CNI cluster, the Ingress cluster, and then the one we're in now is this single node, which is kind control plane. So in this set or this step, what they want us to do is they want to take the CIDR range of this cluster and grow it or move it from 10.96 to 100.96.
Oh, you mentioned something. Why would you do that? You mentioned
why you would move it? It depends
well,
on your network.
growing is one use case, right?
Growing is one, yeah, if it's a different size. So
Yep.
CIDRs are networks, right? So these make up when you see a CIDR like 10.000 or 10, let's make one up, 10.1.2.3 or .0/24. What that means is the network that starts with 10.1.2, each one of those is an 8-bit octet. And then this number at the end is the number of bits that's masking the network. So when you say my CIDR, my classless interdomain routing, whatever, my network of /24, it's saying everything after the masked bits is the number of IPs I'm going to have. So if I do 10.1.20/24, this is made up of 10.1.20 through 255.
200.
There's 255 IP addresses in that CIDR.
And you're going to have more pods than 256. You're in trouble, so you have to update the DNS.
Exactly. So you want your range to be bigger. You could drop to a full 6 or a smaller 16 number, which actually grows. So you're only paying attention now to 10.1, and now you've got 255 and 255. So you've got all the addresses now in between those two.
Yep. And then what do you do in production when you have 256 pods live with the old IP address, and then you're going to change this to have new IP addresses?
You try,
right? So that's kind of the type of things like I would like to see in the exam, right?
I mean, these are the things that normally you would do while sizing your cluster when you're initially going in.
Planning, and some people just delete the cluster and do blue-green, right?
Yeah, your network folks are going to tell you this. What you have available to you, what ranges. Now, this one that we're using in the example is not growing it because it's already a 16. It's changing it, and that could be because the 10.96 is used by some other cluster or some other thing that's in the routable area you're in.
Yep.
So they're moving us up to the 100.96 for whatever reasons. So in order to do that, we need to get onto the node itself. So we're going to exec into that first kind control plane node. And inside of here, we're going to go edit the static pod definition for the API server first. And if everything under etc Kubernetes manifests on a node by default is a static cluster, the kubelet will start these whenever it sees them, and it'll change them whenever you modify these files. So while we're in here, there's a bunch of stuff. This is the API server for the cluster, and it's got all the configurations. I'm going to search for the 10 dot down here at the bottom. My font size, okay?
Yep, we can see it. So in there, you will look for something cluster IP range, right?
Yep. Service cluster IP range is what we're really looking for. You can see he's highlighted it in the book. And we want to change this 10 dot to 100. So it's going to insert a 0 there. We'll save and quit. Now immediately.
One second, Eric. A tip for the exam: if you CD to that folder manifest and do Vim or VI, I don't know how the computers will be set up.
Yep.
Vim, depending how you set up, will create a second temporary swap file. And if you have that second swap file, the kubelet will see that second file and start like modifying it. So then you have two files with the same content and you get into trouble. So please avoid CD into that folder, or just copy the file to the home directory, do the edits there, and then copy it back.
Even if it's not named .yaml?
Even if it's not named .yaml.
Interesting. Yeah. I didn't know that.
I could have gotten lots of config files overridden as far as I remember. But can't. Yeah.
I got in trouble in exam practice or something like that. And it was because it was creating a temporary file.
Yeah,
was
it we or okay.
Well,
so weird.
I didn't do that.
Small tip, but this is why it worked, because you didn't CD into it.
Yep. So I edited it, and what you saw here was I was looping over git pod A, just waiting for the API server to come back up, because as soon as I made that change, the kubelet noticed it. It destroyed the old kube API server, which gives the cluster is invisible to you now because there's no API server. And then I kept trying until it came back, and there it's back. API server is listening again. And now, what was the next thing we're doing here? We're looking at, next thing we got to change is the service in front of CoreDNS, because it's listening on the old IP address still. So then this one was interesting. I've not done this before. So we're going to go in and we're going to edit the CoreDNS service. You can see there it is, listening on 10 dot. We come in here, and this is just a standard Kubernetes service, as we'll talk about later in the chapter. But here's the cluster IP. We'll put 0 on that. And then there's another thing that automatically gets created. Both of these automatically get created if you don't set them. But that cluster IPs, plural, has to match. Or the 0th, the first element of this list always has to match the cluster IP, according to the Kubernetes API. I actually had to go look that up. So if you go to the Kubernetes docs referencing the API, you can find out all this kind of ridiculous information. And if we go to, I had this scrolled to it.
I had the same question. I looked it up. What's this guy with this thing with an extra S?
Yeah. So here's cluster IP. We all know that because that's the cluster IP. Cluster IPs is a list of IP addresses assigned to the service, and it says the client. If this field is specified, clients must ensure that element 0 and cluster IP are identical. Are the same value. Okay, good to know.
You know that part.
These are things I've never. They'll automatically set themselves if you create a service normally, but and it can have up to 2 entries. It's a list of 0. I'm sorry, 1 or 2, and the other was for like 2. I guess for if you have multi-homed. Just an odd, trivial service thing.
IP family, interesting. Okay, which is IPv4, IPv6. I think that's
is that what it's for? You think?
Yeah, IPv families. Okay.
That makes sense. Okay. So anyway, so I've changed both, and now what was interesting, really interesting, more so than that triviality, is that when you go to change this, you're not allowed to. You're not. Nope. The API server is like, no, you can't change that. And you're like, okay, whatever. So VI is going to keep the temp version of this, or whoever is going to keep the temp version of this sitting around. You can go ahead and tell kubectl replace, which is kind of like do what I say. Replace this entity with and force it. You say just do it.
Yeah.
So QRT is the force, I guess.
Yeah. So delete the old one, create the new one, and now that step is done. So I ignore that error. It's a known. It's supposed to do that error. Disregard it, and then replace it. So now we've changed it. If we do a, oh, I'm sorry, I skipped that. We're going to go now down to, we need to edit the kubelet config. I'm sorry, I've talked forward past a lot of this. The kubelet config is a config map, and it has cluster DNS. This is where the kubelet, how the kubelet knows where the cluster DNS is to talk to or to set in pods. So we're going to edit that. When we save it, now we need to kind of reconfigure the kubelet to use what's in there, because the kubelet's running right now. It's not picking up that change. So you actually have to use kubeadm.
Yeah, I had a question on that one. We can double check, but that config map is updated when if you restart the kubelet, it will use the information from varlib, which I think you jumped that thing, or you're going to do it afterwards.
It's going to happen right now. So when you run kubeadm upgrade on the node with a specific phase of kubelet config, it comes in here, it says, hey, you've modified the recommended number to the 100 number. And now it says it is writing kubelet configuration to file var lib kubelet config YAML. So it's doing the edit for you. And
in the book, I think that's why I was so concerned. In the book I was reading, I thought he was telling people edit the config.yaml. I was like, then why do you need to use kubeadm at all? Maybe I didn't install with kubeadm, but now I see.
Are you talking about this little snippet here next to the figure?
Yeah. Let me see.
Yeah. So the file replaces. So yeah, this is a little. Yeah, that
picture. I think I got caught in the picture. Like he was telling me to update it, but it's not actually.
So yeah, changing the config map feeds this kubeadm process, which then updates the file on the file system. And I think the reason why you would do this way is because if, depending on where you've installed things, it could be somewhere else, right? You could customize.
Yeah, it's a handy helper, right? It's a handy helper by kubeadm, taking like the information from the config map and put it into config.yaml, which I know where the config YAML is, and I know how to edit it. I go just edit there and restart kubelet, because maybe I don't have kubeadm. Usually I don't have kubeadm.
Nope.
But that's essentially, it's a helper to help you like change that file based on the information in the config map. Interesting. I learned something new today.
Yeah.
Demo reload, which I always forget about it. Yeah. Next one.
And then we're going to do the normal systemctl to tell the daemons to reload and restart the kubelet. And then I like to do a status on it. And see, there it is, active running. That tells me the kubelet is back up. So to test things out, we're going to go ahead and fire up a pod. And we're using my buddy. I know the guy who writes this. He's my boss at Docker, Nico Kbar.
Yeah, that's the image I use a lot.
NetShoot's awesome. So NetShoot is a cool image that has a bunch of network troubleshooting tools baked into it. So we're kicking it off, and we're going to there it is running. So now I'm going to I put a wait in there just in case it took a while. Now we're going to exec into it. We've got a shell, and we're going to look at what the resolve conf. So the resolve conf gets written by the kubelet, I believe, as it creates the container, or it's fed into the container runtime engine to fill this in correctly. And sure enough, its name server, it has the correct 100 dot in it, which is what we expected.
Yeah, and then this is something that you can influence through the pod YAML. If you open, do you want to see the pod YAML and see the DNS information? If you do it will have the information about the YAML and how the pod wants to receive the DNS information. If it's going to use that then, or you can choose to take the DNS information from the host. So there's situations that you need to like modify something in production, that DNS is down, and you need to use another one, and how do you switch it, and back and forth. So if you search here for DNS, I think DNS policy, it says cluster first.
Yep.
We're not going to dig into this, but this is homework. Search what it means, cluster first, versus the other options, which DNS is different. This value will be different on the DNS pod. If you check, and the reason is the DNS one is taking the DNS, like the actual DNS values from the resolver, from the host, and then this one is from the cluster.
Cool
So
stuff.
you will see a difference between the DNS pod and then your normal pod. So it's cluster first.
So yeah, so that works. The next thing is we're going to do an NS lookup while we're in here. And sure enough, you see it hitting the correct name server and getting back the result for the internet-based example.com. So that's changing your DNS CIDR. I think we talked through question. Anyone have any questions on what we did there?
So question, if my DNS resolve.conf says my DNS server is sitting on 100.96.0.10, it means that this pod is going to do a UDP call to that IP address, right? Which is the pod of the DNS listening on that service. So that's the reason we modified the DNS service. It wasn't that value. So they're actually accessing it by IP address and not the normal DNS discovery, because it's like DNS needs to come from someone. But that was the reason you modify the service on the DNS, because this at this point is where you need it, right? That cluster IP to map to the DNS pods.
Right. That is correct. Okay.
What's the next thing?
Moving along to the CoreDNS, talks a bit about why wouldn't sorry?
Scaling them. The next thing.
Yeah, we're gonna look at that. But one of the things he somewhere in here he talks about, why wouldn't you just modify the host file on all the nodes, it would become onerous to try to keep those up to date across all the pods as they're getting updated. So this is why we have DNS and having it be scalable is nice. So I'm gonna make sure we're in the right context. And we're going to look at the config map. So you can see CoreDNS, he mentions it here, that it's has a config map in the kube system namespace. And if you want, you could look at it if you wanted to. There's nothing really interesting in it. But that's it. That's where it's keeping its config for itself. And you can see that there are two of them. Kind of the default kubeadm setup. You end up with 2 CoreDNS servers.
HA, high availability.
It's deployed as a standard deployment. That's why it has 2, because the deployment says have 2.
Yep. In case you need to upgrade the CoreDNS, you do it in a rolling rollout, so you always have DNS. DNS is not down.
So then he goes into, we could scale it up to 3 if you wanted to have 3, and sure enough, all of a sudden Kubernetes does its thing.
So why would not have CoreDNS be a daemon set?
You might not want it on your workers for various reasons. You might want to control where it is. I guess you could use node affinity to control that, but that's a good question. Why, Carlos? Why don't I want it as a daemon set?
It's a waste of resources, because say if you have a 1,000 worker nodes, probably you need a proportional number of CoreDNS, maybe 7 or 10 depending on the load. You don't want 1,000, like waste 1,000 pods on CoreDNS just for DNS. So that's why there's a proportional autoscaler out there that you can help install, and it would proportionally scale CoreDNS proportionally to the number of nodes. And that's something that is used a lot in production on the cloud. Well, anywhere, right? It's open source. It's from the Kubernetes SIG. That was the short answer.
Cool. So what happens if you scale it to 0?
It's always DNS.
DNS is gone. So now let's make a deployment. So we're going to create a deployment called Apache. That is the Apache HTTPD image, and expose it with a service. There we go. There it is. So we got a cluster IP. And now we're going to jump back into that pod we were running, that NetShoot pod, and let's try to get its address. We're going to do a wget on the Apache service,
Nothing.
and we can't figure it out. Well, obviously, because we don't have a DNS server for it to figure it out. If we were to take that IP address, the cluster IP of the Apache service, and throw it into the etc hosts file here in this NetShoot container,
Yep.
do the wget, obviously it's going to work. But again, this is to his point. You wouldn't want to be modifying all of your pod's hosts files every time a new service was brought up or shut down, because you'd have so much churn going on between the pod, however you would be setting up that host file. Anything else about that section that people want to talk about before we go on to pod connectivity?
No, the etc host very useful when you're dealing with a CVE or an SRE problem, right? Customer impact incident, and you want to fix something quickly, then /etc like. And this is for people that are like trying to learn Kubernetes. I will always go back. Kubernetes is based on networking, storage, and Linux. So if you're not sure what to learn next or with Kubernetes, I think having a good fundamentals on Linux and networking goes a long way, because a lot of people get in trouble with Kubernetes. They're trying to like blame Kubernetes on all these things and complex things, and at the end of the day, you're just running Linux programs.
Yeah.
Right. I don't even going to use the word process or containers. Just Linux programs that communicate with networking, DNS, like. So that's the tip. Like, learn some of the fundamentals. That would be a long way. And don't blame Kubernetes, because you can blame it, but a lot of people blame it for things that are just like, that's how storage works. That's how block storage works. That's how Linux works.
Yeah, and one thing to keep in mind when you're doing this study, is when you're using kind, networking is a little weird, because everything is abstracted and virtualized away into the Docker networking that's happening between, especially when you have multi-node clusters in kind. It's awesome that kind can do that for you, but just know that you might think that things are connected in a certain way, but they're all kind of in that box, that kind of box, as opposed to being on your local, like if you're doing this from a Linux workstation. You might think that it's available to you outside of kind, but it might not be, because of what's being exposed or what's not. So,
Yep.
Okay, pod to pod connectivity. So, talking about how pods talk to each other. So, we're going to bring our CoreDNS back up, because that would be a problem if we didn't. I didn't set my context. Oh no. I know I'm in the right context on this one. So let's take a look at what pods we have running. So there's CoreDNS is back up to 2, and everything we've got from the prior examples. So with this one, we're creating a specific namespace, and he's using a name like this because this is the kind of namespace names you'll see in the test. They'll be computer generated. So we create a namespace, and you can see now that's added to the list of namespaces. And now we're going to deploy into it a Nginx image and expose it on port 80. Take a look in that namespace. Those are the two things we have, and it is got a ready 0. It still must be pulling the container. Let's do it. Oh, it's running now. By the time I got over there, it's running.
Wait, now you did the creation of the deployment and expose on the same command?
It's a semicolon.
Or you have 2 commands in there?
Yeah, it's 2 commands.
I
just copied and pasted what he had.
I was like, man, create deploy has expose. That would be cool. Like,
that would be cool, wouldn't it? Some super deploy. So no, it's the 2 commands. So now we're going to shell into the Nginx pod that came up. I just did autocomplete on that. So we're in there, and we're going to do we're going to try to curl Apache service, which is what we started in the prior step. Could not resolve. Anyone know why?
Wait a second. So
Apache
you
service, come out here and I go to service. There's Apache service right there. Why? And sorry, K9S is like a fancy, pretty CLI or whatever IDE for looking at Kubernetes. So if Apache service is there,
where's NetShoot that you're doing the curl from?
I'm doing it from the Nginx container I just started. So we deployed Nginx, and I exec'd into it, and I'm doing it inside of that. I'm doing a curl on Apache service.
Are they in the same namespace?
No, they're not.
Then we need to include maybe the namespace with the service.
Yep. So Apache service was in the default namespace. If I pop back over here, you can see that over on the left column, as opposed to Nginx service, which is in the and the pods are in the CO1383 namespace. So if we append .default to the host name, it works, and that is because CoreDNS is automatically it's namespace specific, so that that's the fully qualified name, default service cluster local.
Not that you cannot like curl Apache service or curl something with the service name. When I said, not that you are required to put the namespace. It's just that service needs to be in the same namespace.
Right. If not, so what's happening is if you look at the resolve conf, the search we're doing is in our namespace for a host name. By adding default, then the other searches come into play and it says, oh, .default .service.cluster.local. Yes, there it is, and it finds it. Yep. So when you just do a host name all by itself, there is no Apache service in either this domain, that domain, or that domain, so it doesn't find it. So now I jumped out of there, and I want to get the IP address of the Apache service of the pod. So I did an O wide on it, output wide, and that gives me the pod IP as part of one of the columns. You go back into my Nginx container pod, shell back into it, and if you wanted to get to an IP to another pod directly, if you knew their IP address, like you pulled endpoints or something, if you somehow figured out the IP address, even though it's in another namespace, I can get to it. And if you replace the dots with hyphens, and then put the fully qualified, path out to, put the namespace in it because it's going to need it, you can get to it. And this is indicative of two things. One, Kubernetes networking guarantees any pod can get to any other pod with no NAT or anything, as long as you know where it is.
Wait. So it doesn't mean like, I thought Kubernetes has namespaces, and if I put this stuff in this namespace and this stuff in this namespace, it means two separate things, and they can never like talk to each other.
Carlos is lobbing a softball up, because number two is that it also means you're not using network policies to restrict it. So namespaces are not security boundaries. They are namespacing. They are just a way of separating
naming things. It's for naming things.
And naming is the hardest thing in computer science, as we all know. It also is just simply a way to make things, is a way to kind of put things together. It's like a folder in your directories, in your file system. It's not a security boundary. However, as we, if we get into, I don't think we get into network policy in this section, but network policy is a namespaced thing that allows you to say what can talk to what, and what can't. So this is telling me you found it and it's connectable, but there's no network policy blocking me from getting to it.
So this is very interesting. So it means you can use the IP address to reach. You can every pod gets a domain name, I guess, by default, using their IP address in front of it. I was going to say, well, if I'm a hacker, like you can have there's a finite number of IP addresses I can try to scan ports, but I don't need to know the DNS. I can just go directly on I can guess All right, I make it faster. I can guess what is the most common CIDR in Kubernetes that people use by default, right?
Well, you would
And
know
just
your
like-
pod CIDR if you've gotten into a container. You could look at what's my pod CIDR or what's my pod IP,
Yep.
and then you could say, oh, well, that's probably
Yeah,
in
all
the
pods.
/16 or /24. Let's just roll through the DNS and look and see what I've got.
Yep. Yeah. All pods are sitting in the same flat network, but usually, right? You configure things by default. Yep.
So that's the end of that pod to pod networking. But let's so now we're going to shift to Ingress. So Ingress, I was surprised he did this before service, but he did. So we're going to hit it in that order. Ingress, I
true.
like the diagram he has here. It's going to basically, if you've ever done use Nginx or Apache or HA proxy or F5 or whatever to do host or path-based routing, level 7 routing, that's what this is doing. It's saying, hey, for a given host name or URL path or whatever, I want to route the traffic to a specific service behind that. And I want to do, it's like reverse proxy, right? It's how you handle that in Kubernetes. So you don't have to worry about what is nice is that it abstracts it away from you. You don't have to care that it's Nginx really. I mean, there are some annotations you could use, but generally you say, I want to write an ingress pipe that says, take traffic that looks like this and send it to my service, however you want to do it. And the cluster admin generally is the one who sets up the ingress controller, which understands the ingress object and does the necessary things to make that routing be true. So you could have Nginx, you could have traffic, you could have HA proxy has one. There's a bunch of ingress controllers. Contour uses Envoy on the back end, I think. All sorts of different ingresses you could use.
Or even the cloud provider has.
Oh, and yes, that is true too. Cloud, managed cloud is going to have their own examples as well. So we're going to start 6.3.
And one thing that people maybe don't always associate ingress with, like getting traffic into the cluster. There's nothing stopping you from creating an ingress inside the cluster for communication between pods, where like one pod needs to hit something with / something, go to that service, go to that service, go to this service. There usually is like ingress or going into the cluster.
So I'm switching over to a different kind cluster. There's a kind ingress, which he mentions. It's down in the appendices on setting this up. And basically, the only difference in it, I'll actually show you what the difference is. You look at the kind config being used instead of a default config where we've got a specific config file. I've given it a name just so I could keep it, so I could run them multiple different clusters and refer to them. But other than the name, in the node for the control plane, which is it's a one node cluster, it has a mapping to basically bind port 80 to the host port 80, so you can get at it from outside the cluster. And it has added a label, ingress ready. The Nginx ingress he's using in this example relies on that label to know what nodes to deploy the controller to. Because you can put, in real world, when you deploy an ingress controller, it's basically installing Nginx servers. And these things are going to be network heavy. They're going to take traffic. And there's performance and security reasons where you might not want to run these on every, or willy-nilly on any given node. So you want to label the nodes you want to have ingress running on appropriately. A lot of clusters I've seen people do it where they have a cordoned off section of nodes that are just for ingress and egress. And they will run all your traffic is going to flow through those and then horizontally across the cluster underneath them. Carlos, you may have more, and Sevi, you may have more experience.
How is that kind doing it in this case? Is it putting a
just labeling the node?
Well, labeling alone doesn't guarantee that you are going to land on this.
It's labeling the node, and then the ingress controller deployment YAML is tied with affinity to that label.
Okay.
So it's saying only deploy if you don't do this. So if you're doing this example in the book, you're watching this recording later and you're doing this example in the book and you deploy your ingress and it sits there pending, do a describe on it, you will see I'm waiting for something with ingress ready to be true, a node with ingress ready true.
Yeah.
And so that's why you have to have a different cluster, because that's not present on the default cluster.
Default one. Yep.
When you bring it in.
And remember that this is a kind config that you can have multiple nodes defining here.
Yes, we'll see that when we get to the last one.
Yep.
So I've switched over to that cluster, and I'm going to apply from it's going to pull right from his GitHub repository the ingress controller YAML, and you're going to see a bunch of stuff get created. So there's the namespace and a bunch of things. And if we look at everything in the Ingress Nginx namespace, I paused long enough. It's all done. These two are completed, and this is running. And so our ingress is ready to go. When you see this controller being running, we're good to go. On bigger clusters, you'll have multiple controllers, and you'll see them. And if you do a wide, you'll see them spread across whatever nodes you labeled for them to start up on. Now we're going to create a deployment called hello, and it's going to use Nginx demos hello, and it's going to specify a port 80, and we're going to expose it.
Well,
service.
One thing, this ingress deployed, if you look at the list at the top, if you can highlight, there's a line that says ingress class at the bottom. Yeah, that one.
Oh yeah.
That's a it used not to be in all Kubernetes present. So this is a Kubernetes resource ingress class that you can configure, and it's similar to kind of like say storage class. So you in the past when you created an ingress, you had to have an annotation in it to say this ingress is I want to be handled by this controller. So the ingress controller will know like what are the ingresses I need to manage. So then came this ingress class that you can create an ingress class, and then you'll be able to put like a section. I don't know if his example has it. You can say ingress class LB if it's like Amazon load balancer or Nginx, or you can say if you have like one ingress class or multiple, you can set one of them to default.
Oh, cool.
So that's a little bit better on like associating an ingress with a controller. If you want to learn more about controllers and what this validation webhook, that line that is there, you can watch the other recordings we did a KubeBuilder book club series on controllers.
That's cool. I didn't know that.
But yeah, that's why you will see a lot of examples online. Some of them will have the annotation, the Nginx. Some of them will have ingress class, like a field in the spec.ingress class Nginx, and people always get confused, like which one do I use and which one is better. So that's the answer.
This feels like the newer way.
Yeah, the ingress class is the new way.
Cool. We deployed a service and a deployment behind it, and now we're going to create the actual ingress object. So we got a controller to do ingress work. We've got a deployment that we want to make with a service that we want to have the ingress connect up. So now we're going to actually create the ingress. We'll look at the YAML in a second. So we've applied it, and if we look at our ingress, we see it there. So we have hello. Check. It has no class.
See, that's the spec.ingress class.
So that's cool. So I could actually have multiple ingress controllers, and I could say, in this ingress YAML, when I look at it, I could say use class Nginx or traffic or whatever.
Or cloud provider X cloud. Yeah.
Nice. I like that.
So here's something cool that I said like 2 years ago when it came out. I wasn't aware. If you go to a terminal and do kubectl create ingress-h, there's actually a command to create an ingress with kubectl. You don't have to have a YAML. So if you're doing a presentation or something like that, you can do -h. And then in here with one-liner, you can create an ingress. You don't need to like mess around with YAMLs. Also for you can there's the first examples are very good. Like you say, create an ingress from this service, rule port 80, and send it to the service, right?
When
And
did they add that?
I think it was 1.20, maybe.
Did not know
I
this. I
cannot
always just go
remember.
over to the
I
Kubernetes
do not
doc and copy it.
So if
Right?
in the exam somebody asks you like, create me an ingress on this and that, don't waste an hour trying to fuss with the YAML file. Just find one of these examples and actually probably will be here, and then just kubectl done, like 1 minute.
Nice.
Just a tip.
Very good. Okay, so I'm doing this a little different than his book because I want to be different. In his book, he's saying let's get into the control plane and edit the etc file, the etc host file, to add hello.com as the same IP as the ingress as the control plane.
Ouch.
You can do that. This is a
Yeah.
kind cluster. Who cares? I don't like to mess with my host file. I just don't. So you can do the same thing. And the only reason to do this is so that hello.com resolves. And you want the header to be, you want the connection to be going to hello.com so that the ingress knows where to send the traffic. I'm doing it differently. So curl has the ability to modify the HTTP header. And I'm saying, hey, I know I'm going to ingress control plane from outside here, but I really want you to make the HTTP header say it's hello.com. This is what the ingress is triggering off of. So I can do that and it'll work.
Yep.
I don't do that, it's going to say, I don't know.
I don't know. Yeah.
I don't know what 404. I don't know what you're talking about. So that's just a little trick that I do.
And it's because, look, take a look at the ingress. Do I keep see? Oh, your recording mode. I was going to say, print the
we're
ingress.
going into it right now.
Yeah, it's doing a hello.com. Yep.
Right. So you can see here, and this maps to here, kind of. He's adding some stuff here. So we see the spec for the ingress. This is the host hello.com, and it's set up to talk that host talks to the backend hello service on port 80, and there's no path defined here. So anything going to hello.com is going to end up going to the hello service on port 80. In the example he lists, he's saying, let's go ahead and modify this to have another rule. I'm going to skip this because it's not critical right now. And we're running late on time. But the idea being, let's add Nginx, which actually doesn't exist in this cluster, but whatever. That listens on port 80, and that way, if and on path app exactly. So if hello.com/app comes in, then the ingress would say, oh, don't send it to hello service. This one wants to go to the Nginx service on port 8080. So now you have two different paths routings for one host. If you didn't type exact here, by the way, I forget the other options here, but anything that began
Prefix,
with app would trigger it.
It could be prefix, it could be exact, or implementation specific. One thing that I want to mention here, Eric, if you can highlight the line that says number 80. One of the things that my pet peeves on this is on in terms of usability. I don't like to put number in here, number 80. What I like to do is name. And the name of the port on the service, not on the pod container, on the service in here. And if you are using OpenShift, the number that you put here actually is the pod, not the service. But anyway, on this one is the service. So instead of number, you can put name space and then put the label of the port. And I will add this. My next pet peeve is on the service, name your port and do not name them the way that you see in the book. Sorry, Chad.
Naming,
put HTTP or put HTTPS, because if one day you're using Istio or you add Istio, you're going to waste a full day, maybe a week, on why Istio is not working. And it's because we still have some conventions that is reading that name on the port and it's seeing like it starts with HTTP, then I can work with it and do things on it. If it says a number like he put in there, or something else, or web or app, then it doesn't work. And I see Sevi laughing. I don't know if you want to add something to that about Istio, but use names.
Yeah, I agree. Also for readability, even for that, it's just not helpful, I think. Yeah.
Yep.
But thanks for raising the Istio convention.
Okay. I'm not going to do, there's some additional things here where you can set that up and whatever. I'm going to skip out of that as far as showing the Nginx thing. It doesn't really work because you don't have an Nginx, a service named Nginx anyway. But
Yep.
So let's jump to services.
Ingress, yep.
Say what?
No, and I agree. Like, it's feedback for the book, right? It'll be, I think, as a lot of people learn service first, and then they learn Ingress, because the Ingress depends on a service, and trying to explain that in Ingress, the thing that it does is routes traffic to a service, that you have to put the service information, and you don't know what a service is, then it's a bit confusing.
So service, I'm switching back to my original cluster. Service is basically just a way to group a set of pods by a selector. So you've got a deployment that's deploying a set number of pods that are going to move around ephemerally all day long by Kubernetes whenever it wants, and you don't want to have to know what those IPs are, because they're, it'll be 1, 2, 3, 4 now, it'll be 1, 2, 3, 6 tomorrow, right? So you have a service in front of that to group them, and usually you're using it for the DNS aspect of it to say, I want to talk to service Eric all the time. I don't want to talk to Eric pod X53, X58, whatever, right? So the service groups it and gives it an IP address and a DNS name. And it uses something called endpoints. There's an object type called endpoint, or resource type called endpoint, to keep track of all that. So right now, our Apache service with one replica has an endpoint, and that's the pod IP and port that the service is going to send the traffic to. If you were to talk to Apache service, it's going to send traffic. That's the pod IP of the one replica. If I were to scale that up to 3, and then this isn't in the book, but I decided to add it.
Yep.
Now the endpoints are going to be, there's 2 of them because I didn't wait long enough. But there will be 3. Let's copy that and where I'm not in my little script. There. Now we have 3 because I scaled it up. You could use endpoints if you wanted to really talk to an IP address. You could say, hey, Kubernetes, what are the endpoints for Apache service? And then you could call them directly if you wanted to. You could do the service's job. But part of the service's job is to keep endpoints up to date.
Actually, that's a good point, Eric. There's applications, for example, HTTP2 or gRPC, that do client-side load balancing. So you and your Go code or Rust code, you can do client-side balancing. So you need the IP addresses. So if you're inside the cluster, you would use this information, or you can get it from DNS. But that's true.
Yeah, this is a better way to get it because
it's DNS. Yeah.
So now we're back to, I brought it back down to 1. So there's our 1. And so there's 3 different kinds of services you're going to mainly see. There's only 3, right? There's different flavors of them, but there's 3 service types.
Yeah, there's a load balancer, no port, cluster IP, and there's one more.
What is the other one?
Anyone?
I know there's headless cluster
external.
IP. External, but isn't that external is it a separate type, or is it a form of cluster IP?
At the end of the day, all of them cluster IPs. No port, load balancer are cluster IPs, and then they build on top of it. Except none, right?
Yeah.
External name. Yeah, Mohammed got it correct. And we use that one in Knative a lot. That's the only reason I know to make like external name also is a way of like you can put like a domain name in there, whatever you want, that points to a pod sitting on another namespace, for example. And you don't need to know like the name of the namespace that you're accessing.
Yeah. So I created a YAML file. So I did a kubectl create with the service info, and then did a dry run client to say, just do it here and output it to YAML locally, because I don't want to deploy this yet. I want to actually mess with it. This is how you, again, in the tests, this will be your best friend, creating YAMLs rather than going and looking up and copying them from documents. So here's the service I created, and there's, like we were talking about earlier, the default naming is not very pretty, but it's functional.
Yes, this is the line that we were talking before. If you kind of were lost, it's this line. So best practice should be named HTTP or HTTPS.
Oh, that's you're talking about the
feature
port. This is the actual. Yeah. Oh, that exactly. Well, this is the service. This isn't the pod.
No, the name. Like you want to put a name. So if you want to talk
Yeah.
about those things is in name,
Yeah.
you will put HTTP, and that's for Istio, and
Right.
that's the name that you're going to put in your ingress. And
Oh,
then
gotcha. Yes, absolutely.
and then
Yes,
in
for
here
ingress.
at the bottom target port, you will put HTTP here, and then you put HTTP in the container port in the pod.
Yep.
Then it's names everywhere, so you don't have to keep asking or finding or googling or like asking like which port number do I use where? Is it the service? Is it the is it the pod? And get all confused.
Yep. So the cluster IP, what is he talking about here? So we're going to go through. He's just showing that its name is horrible, but it is what it is right now. This is saying listen on port 8080. So this service will listen on that port and on TCP protocol, and it will send all traffic to the target port on the pods at port 80 in this case. Or if, like Carlos said, you could have a name here and it would refer to whatever the pod was defined for its port. And it's going to the pods it's going to service all are going to have the label app with a value internal -service.
Pods.
And it's a type cluster IP. So that's that. In the example he goes through, he says, you can have more than one service or one port listening on a service. So if we create a copy of this, and we'll call this, in his example, he calls it search. And it's going to listen on port 9200 and send traffic also to 9200.
Well, one clarification, Eric, when you say port on the service, the target port I usually associate with the verb listen, and the port in here I associate it usually with configuring the routes or IP tables, or because the service is there's nothing listening. When you create a service, it's kind of like it influence information to configure listening on the proxy. So yeah, both are kube proxy is listening, right?
It is, and I like to. So I get what you're going at, but from a CKA point of view, I get it. Yeah, totally. I'm a developer, so I think
we're creating an abstraction for you, right? You don't know anything about pods. There's a service that it listens.
Yep.
So one thing that I will say, protocol
magic happens and traffic is ingested, if you will, or it is sent to this port, but it ends up going to that port over there. And yes, it uses IP tables generally to work that magic, or something else like eBPF or whatever. But I see Mohammed. Yes, so node port is the next service, and it does what you're thinking, kind of. So we've added search. The other thing you can do here that I had forgotten about, actually, you could change the IP, or the cluster IP. We saw that change when we did the DNS stuff, but you could set it to none. This is now what they call a headless service. It has no listener, really. It's mainly used for collecting, and then you could get the endpoints and go after these things yourself. But there's not going to be anything listening on the cluster service cluster IP itself. So if we do that and we apply it, now if we look at it, you'll see that it has none for its cluster IP. And it has these ports. So that's interesting. But to the point of the next question, node port, which is...
Oh, sorry about the none. You had a question about the none? When people use none?
Oh, yeah. What's the practical use of that beyond what I was saying before? If you just want to use endpoints on your own.
So MySQL, right? When you deploy MySQL or Postgres, the database, that if you have one master, one of the pods is it's a stateful set, which is a stateful set. You have one master, and then the other ones are the slaves. I'm sorry for using those words, but one is the
workers.
Primary. The other ones are the read ones, right? The read replicas. It's not a web application, right? It's not HTTP traffic coming in, so you really don't need like a load balancer in front of it. You just need to know like the IP addresses of each one and know which one is the first one and the other ones. Or the read replicas can find the primary one.
So like I was saying, so if I were to do get endpoint, no, it's still none.
Yeah, there's no service, like there's no load balancer.
Right, but there's no pod IPs being listed behind it either. So you'd have to inspect what's the point then of the service?
I'll do the I'll put some homework. I'll put some links in the Slack. I'll double check on
Okay,
that.
yeah. I mean, I get what it does. It's just the practical uses. I think I know where you're going. It's just not gelling in my brain. So now we're creating a node port type service, and it's very much the same. It has a type of node port now, and it has a node port defined for the port. So this is going to take. It has a cluster IP port of 443, but it has also a node port of 30,000, which will bind to whatever host this ends up running on.
Yeah.
Well, no, how does that work?
So this is a security. This is something that you need to learn as an admin, as a security risk. That the minute you're giving power to the let's say Kubernetes, that the minute that somebody does a YAML and puts no port here, you're opening that port on the physical machine or the node on that port, and now traffic can come through that port, right? You just open.
So 30,000. It's been a while since I've used a node port. It's often used in development sandbox clusters, just for simple if you don't have a load balancer or anything. But does it bind, in this case, 30,000 across the cluster on all nodes, and then route the traffic internal, or does it bind specifically on one node?
Yes, that's also a risk. Like suddenly you have 5,000 nodes, 5,000 IP addresses listening on port 30,000. Yeah.
This is very similar to. There's a similar concept in Docker Swarm. If you were old school days, you can bind a port on the host, but again, same example. It's like you don't want to do that for anything outside of maybe developer troubleshooting.
And you would do that in like maybe legacy, at least in AWS, in legacy things. When you have a classic load balancer that you're trying to put, it needs the node port of the host, the instances. But now the Ingress and load balancer, we told you put, expose the IP, the pod IP, which is like available in the VPC, and you don't have to send traffic to the instance.
Right. So now we can apply that, and if we look at it, we see that I hate this notation.
Because
this does not say what it is to me, but because I'm always used to like tunneling and saying, oh, outside, inside, but this is just saying both of these, this port and this node port are listening. So you could talk to it internally on this at this, or you could talk to the node at this.
On any node, and then talk there.
Yeah. And the range has to be a high range up in the 30,000 to 32,768, which is always,
Yeah. And you can set that number. Where you get into trouble is if something else took the number, and then you put in like 30,000 the second time, then who wins, right? You get into trouble.
Right. So finally, we have load balancer services. And this is always fun when you're doing it locally because you don't have a load balancer built into Kinds. Generally, when you see load balancer services, you're in a bigger cluster, or when you see them being used, you're in a bigger cluster that has either in the cloud, it's going to automatically create a load balancer like an ELB or the Google's equivalent of that. Or if you're on, even Docker Desktop is cool. You can deploy this to the Docker Desktop built-in Kubernetes, and it will see a load balancer and mount it to the host's IP.
Yeah,
like a fake load balancer. Minikube will do that as well with a listen, I think, or forward. I can't
tunnel.
remember.
The tunnel.
Tunnel, that's it.
Yeah.
And then Kind, you can do it, but it's well, you're going to see. So it's the same as a cluster IP, except it has a load balancer type. I don't think we're going to modify this. I'm just going to save this. And he's installing the open source project MetalLB.
MetalLB. Yep.
And now if we look, we see that we have, so this is actually a no-op for this example, but he's doing this in case your cluster comes up differently. you need to take a look at what's the internal IP address of your kind control plane node, and then go into. So he's going to curl down the config file for MetalLB, and you need to edit that address. Make sure the first 2 octets are the same as the first 2 of yours, which is we don't need to, and you probably won't need to if you're doing Docker Desktop kind. But if those were different, you'd need to change 172.18 to match your example. We don't really, so this is a no-op apply effectively. I mean, it's there, or the no-op edit, I should say. Now we're going to edit the Apache service, and we're going to basically just come on down, change its type, load balancer, case is important on that. So we're going to make that change, save it, I'm going to edit it. Now if we look at our services, we have a load balancer, and the external IP column now has a value. MetalLB has assigned that. And if you were in any other kind of cluster, it would get it from Amazon. It would go out and create a load balancer service, and then it would get from internally without you having to do anything. It would get that IP address and then plop it in here, and you can then hit that from wherever that load balancer's available security-wise.
And it doesn't have to be an IP address.
It can
give you back a nice domain name.
Is it? I think Amazon gives you back a host name.
Yeah.
GKE gives you back an IP address. Last time I used it, at least an autopilot one. And obviously MetalLB is giving me an IP. So now if I were to come into, I'm just execing into the shell inside of, so I can get into the Docker, the network that it's on. And I'm going to curl that IP address directly, and I get my app because the load balancer sees it and send to, if I had more than one, I could hit it, and it would rotate around, do whatever the load balancer does. So that was load balancers, and would bring us to cluster network configuration. Do we want to do this now, or do we want to hold this for next week?
We can hold it for next week.
Okay, that's good, because like I said, I'm supposed to be on call for something, and I'm having to make sure things aren't on fire.
Yeah, we'll do it in exercises at the beginning of the next one.
Yeah. Mohammed says, just what a private network. Yeah, it is, Mohammed. So it is it is inside your private network, but it is just because it's inside your private network, perimeter firewalls are not really a strong security stance, in my opinion, because if somebody gets malware on a laptop, and they could start poking around, they could get into those. As opposed to if you have a pinch point like a load balancer, that can be tighter controlled, in my opinion.
So the thing about the node, I think he meant the node IP when you use node port. I guess
right.
It's the computer, right? So if my computer is sitting in my house, and it has 192.168.111, it's public to whoever can reach that computer.
Right.
In AWS, by default, we try everywhere to put the worker nodes in a private subnets, so only things inside the VPC can get to them, and not in the public subnet, which means like it has an ingress gateway. So we try to do that, but doesn't prevent you from getting an example from somebody, or you're creating a cluster, EKS cluster, and putting those worker nodes on public subnet, maybe by mistake, and then you get an IP address public, and then then it's public to the world, right?
Yep. The other bit that's related to this, we talked about external name. I remember being somewhere and they were talking about if you could use BGP as a load balancer with external name services. And it's a similar kind of a problem if you do that instead of using like a full-on load balancer. Doing that, you're exposing things out that you don't need to be exposing. It's been a while since I looked at it, but you're trusting that the routing of the network you're giving that broadcast BGP to is only going to be seen by people you trust. And
the other part, right? Listening to that PGP message to update their routes and then interchange their routes back.
Yep.
It's the same thing as install Tailscale, not promoting it. Tailscale is I love that system, right? It's a private VPN thing, and you install it Kubernetes, you install it in your computer, you install it in your home, in your phone, and everybody everything can talk to anything, right? So networking is tricky. So we'll leave it at here. I think folks need to drop out. But Mohammed, thank you so much for sticking around, Ben, and others. Hopefully you enjoyed this, and people that are watching on YouTube, even at 2x, can learn a few tips. We try to drop a few tips, right, for the exam to make it easier. So pick them up. Thank you, Eric, for helping us today.
Awesome. Everybody have a good weekend.